It's completely new for us. We have decided during the conference in Paris 4 years ago that our community will have two new things. The second one will come on Friday, and the first one, the most important one, is that we've decided to the medal for particular things that people have done for this community, scientifically as from an organizational point of view, both take into account if the community thinks about these medals. And it was an idea by Antonio at that time to introduce that medal. We have named this medal after the father of parafluid research, Ron Rosensweig. I think it is nobody here in the room. Ron's book on hydrodynamics, the real basis of what we're doing, and the starting point of all these developments, right? The patent for the first ferrofluid was by Steve Papel, but to understand that really special at that point, that was Rosenzweig's idea, and that was a starting series of conferences that he started. For us as an organization, this is not so easy, since we are not an organization. The International Steering of Magnetic Fluid is not part of some association or something where you be a member. This community coming in these conferences has no legal basis as it makes it difficult to do things like we have done here, to do things like, we make a medal. Nonetheless, we have done what we have succeeded to do. And today, we'll give out the first 3 medals. We decided at that time, and that would be correct, to make a real visible starting of this Rosensweig medal and to say, well, it is 3 medals that we distribute at this time. Now I need to go over the, or you do it, okay. We had a prize committee, and I would like to thank the colleagues that have done the work, Antonio Figueiredo Neto, Peter Kopczanski, and Yuri Riker. They sat together and have looked over all the applications that have been made. Many people have sent in applications and have said, okay, this person would be the right person for this medal. It was a difficult task to decide at that point. And I think I will really switch the microphone of this, because this one does not work. Let me have a look whether I can get this running. Probably this is better. Okay, that works better. The other one seems to work only under certain conditions and not from here. Okay, and now I would like to come to the 3 awardees that we have for the first time of Rosensweig Medal. And the order that I've chosen is not an order of importance or something. It is more technical one, which comes from the fact that not all of them can be here, not even online, incidentally. And thus, I've put the one who is really online with us at the end of this list to hand over the word to him at the end of this starting presentation. Could you please? Okay, so the first one that we have, and that was awarded with the Rosensweig Medal, is Jean-Claude Bacry. I see it from the reaction. He seems to be well known in this community. I think most of you know Jean-Claude did a lot of experiments and experimental work in optical phenomena. He did some experiments, high quality. He did a lot of investigations in pattern formation. He did the first experiments on this phenomenon, which is called negative viscosity. He did fascinating experiments on the Sorey effect with laser grids, highly complicated things. And what many people do not know, if you look into his long bibliography, he did a lot of work on bubbles and droplets. This is often not so much seen, but there are wonderful papers on these things. In addition, he was twice, at least partly, responsible for the conference, for the ICMF, both conferences in Paris. He was strongly involved. And thus, as well from the scientific aspect as from the organizational aspect, Jean-Claude seemed to be for the committee one of those persons who should be awarded with Rosensweig Medal 2023. So I think that is the first point that we could make. Our second awardee is, I think, also known to everybody here, Mark Schliermes. I mentioned at the beginning that Ron Rosenzweig is a father of this overall community of ferrofluid dynamics. And if I say so, one can say that Mark Schliermes is a father of the theory of ferrofluid dynamics. I just in the talk before I mentioned this paper from '72, which is the basis of all these things that have been done. I showed that the theory at that point did not really fulfill to explain the experiment, but nonetheless, it was possible to fit the thing. So the idea behind rotating particles, the diffusion coefficient, the rotational diffusion coefficient of these particles changing in magnetic fields, they are larger, they are agglomerates, but then nonetheless, the theory is stable enough to explain that. That is one of the real basic things for our community. And I think I have looked into the science reports. The '72 paper is his second most cited paper. There's a review paper which is a little bit more cited, but this one is a real basis of all what we're doing in theory here. Besides that, and many of you know that Mark did a lot of work in thermal convection under various conditions, pattern formation things in thermal structures, very complicated theory. And he introduced this word of negative viscosity. And for those of you, the younger ones who do not know this, it is not really negative. It is a negative magnetorheological effect. So the viscosity increase goes down with a magnetic field and an AC field. And he introduced this spectacular word in this first letter together with Jean-Claude Bacry. A lot of important things. He was always hard fighting for his ideas. I remember well a historical scene during the ICMF in Bremen where he entered the stage after a talk to give a contra talk to what has been said there. I was the one who had been talking before, where some controversy was going on theoretical things at that point. Always strongly fighting for ideas, excellent theory, and the basis for what we do in theory. I think the committee has done a good thing at that point to award Mark Schliermes also with the Rosensweig Medal 23. And thus we come to the third awardee for 23 for the Rosensweig Medal. I personally know Elmars Blums since nearly 3 decades or something like that. I was quite happy when I looked to your bibliography, Elmars, that the papers that we have made together are amongst them that you have outlined as the most important ones. That is nice for me at that point. He did tremendous work on convective and diffusive phenomena in magnetic fluids. There are really groundbreaking experiments on the Soré effect in a magnetic field, where he was the first one to show what's going on there, laying the basis for all the things that we later on did together. That was completely new things. In addition, he held up and secured the community in Latvia over many, many years, keeping them active after the changes in the 90s. Aside all these things on convective and diffusive phenomena, which are usually seen, it is often overseen that his lab was famous for producing fluids with mixed ferrites, especially manganese zinc ferrites inside. And I remember well Gunnar's Kromkans standing in the lab, stirring in a pot, making ferrofluid. I was absolutely fascinated at that point. He did the first experiments on the anisotropy of the magnetoviscous effects. Paper that is not often cited, but nonetheless, it was the first one to show that the magnetic field direction is important for the effects that I've just shown before. It has taken more than 25 years to do experiments which could be a little bit better than that was done in Blum's lab at that time. Beside that, he had also a couple of application-oriented questions looking for, like loudspeaker cooling, or a big experiment on the magnetic heat pump, which is known from Rosensweig's book. In addition to all these big scientific achievements he has made, he served for a very long time as a chairman of the steering committee of magnetic fluids in a very difficult time, a time where the number of participants seemed to go down in the conferences, where we had to make a lot of advertisement to get people back into this field. And remember that almost sometimes said, well, the field is going down. We will have to see what to do. Almost I can promise you it is actually not going down. We are still in a good situation. Many people are here. And he organized wonderful conferences in Riga. I've been often there in Riga, Latvia, and it was always a good time. I think a really good awardee for the Rosensweig Medal 23. Now, at that point, I would like to give the word to Elmars Blums. Probably we can open the window. Elmars, I hope we can hear you. We can see you at least and hope we can hear you.
Hello, hello.
Yeah, it works.
Can you hear me?
Yes, we can hear you well.
But picture is not seen.
Pictures well here.
Yeah. I will take some words in thinking for this award. I'm very grateful for the great award given to me, the Rosensweig Medal for contribution to the development of international cooperation in magnetic fluids. It is one thing to receive impersonal awards from various authorities, given for formal results and achievements, and another thing is to raise a recognition from close or dear colleagues who value your activity on contribution personally and in essence. Dear colleagues, I am unimaginably touched and pleased with this recognition of yours. Self-critically, it seems that my biggest contribution to the development of international cooperation of ferrofluid research is the 5th International Magnetic Field Conference, which was organized thanks to Ronald Rosensweig's suggestion. The conference was organized in Riga in autumn 1989 during the maximum of the Baltic Sea Revolution. Even in previous years, magnetic fluid conferences were held separately in the West and the East countries. This time, an unacceptably large number of participants from both the West and East came to Riga. I remember that during the gala dinner of the conference in Jurmala, a united world ferrofluid community was formed in an atmosphere of cordial unity. I would like to express my gratitude to Dr. Rosensweig for introducing me to the international activity of ferrofluids, to Professor Dr. Klaus Stierthat for his great contribution to German-Latvian cooperation in ferrofluid research, and to my teacher, Professor Juris Mikhailov, for his sincere support for my ambitious international activities during severe conditions. Many like-minded people and scientific cooperation partners have appeared over the years. First of all, we should mention the long-term fruitful scientific collaboration with Stefan Odenbach and Thomas Walker in Bremen, as well with Kuldeep Raj at Ferrofluid Corporation USA. Besides, there was established a long-term friendship with Ladovers Vekas, Viktor Bastavoy, Mark Sliomis, Vadim Gogosum, and many, many others. I would like to thank also my Latvian colleagues, Andres Sebers, Mihails Majorovs, Juris Pļaviņš, Ancis Mežulis, and Mitis Sabloskis. Thank you. Vielen Dank. Cher merci. Muchas gracias. Gracias, Emilia. Mīļš paldies.
Thank you very much, Elmars, for this address. Before we now come to the final thing, I have to thank the chair of industrial design and engineering at my university and my faculty. Of course, they have done the work to design and even manufacture the medal itself. We have those 3 medals here, gold-plated, and we will send them by mail. I hope that this will be done within the next days to get them to you, thanks to these colleagues. And now we come to the final part of this medal ceremony, and I'm now happy that, as I mentioned at the beginning, the father of ferrofluid research, Ron Rosensweig, will give an address.
Well, buenas tardes, señoras y señores, ladies and gentlemen, medalist, conference organizer, Professor Modesto Lopez and his associates, chairman of the International Steering Committee, Professor Stefan Odenbach and his members, and distinguished colleagues. I am greatly honored to have this medal carry my name and to learn it is awarded to Professors Mark Sliomis, Elmars Blums, and Jean-Claude Bacry, each of whom I hold in the highest regards for their scientific contributions in magnetic fluids research and for furthering the efforts of others. Mark Sliomis broadened ferrohydrostatics into ferrohydrodynamics, a deep contribution, and he's made penetrating discoveries, and he still is, using just his pen and paper. Elmars Blums focused efforts of himself and Latvia's researchers in Riga's MHD lab, and he served many years as chairman of the ICMF steering committee, as has been mentioned. Jean-Claude Vacry, through experiments and theory, led the very productive French effort that also formed collaborations around the world, from Brazil to Japan and elsewhere. Ferrofluid research for me began as a problem in an energy conversion application in the early 1960s, about 60 years ago. And I needed a more magnetic fluid. More about that later. Soon I began to see a bigger picture, and the prospects fascinated me, just as it has cast its magnetic spell on others. Let's not show those slides yet. I'll call them up when we want them, all of them. No, let's not show them yet. Interest in the field developed relatively slowly in the early years. And then in 1977, which was 43 years ago, I was astounded to receive an invitation to a workshop on magnetic fluids to be held in Udine, Italy in October of that year. The meeting was organized by Boris Berkovsky, Belarusian physicist, with support from UNESCO. It turned out there was much work going on in the Soviet Union. The meeting was attended by some 30 researchers who were widely scattered and mostly unknown to one another. The objectives of the meeting were to assess knowledge in the field, to identify specific problem areas and promising directions for future research and applications, and to assist in the establishment of active relations between national research groups. Now here we will look at this slide. This historic photo shows the group who met in Udine in a former palace serving as a center for mechanical sciences. None of these researchers at this Granada meeting, except myself, and I think all are retired, or here at the meeting, but I think all are retired except possibly Roy Chantrell, who was a grad student at the time. He was actually here in Spain in April of this year at the third workshop on magnetic nanoparticles and hyperthermia held in Santiago de Compostela. At the conclusion of the Udine workshop, there was a determination to hold another meeting in 3 years. And I organized with Mark Zahn a follow-on meeting held in the USA, which we called the second ICMF. To date, there have been 16 meetings in 13 countries: Japan twice, Latvia, France twice, India twice, Romania, Germany, Brazil, Slovakia, Russia, and now Spain. Attendance at the meetings has increased greatly over time, so that was the genesis of these meetings. Next, let me show you a few other kind of historic photos. Could I have the next slide, please? That's the one. This photo shows the ferrofluid spikes as they were seen for the very first time ever. I had produced a ferrofluid many times more magnetic than any before, 5 to 10 times as magnetic. For inspection, the fluid would be placed in a Petri dish and placed on a magnet as seen here. What was going on? What caused these spikes? Martin Coley and I worked out the stability theory and found there was a critical value of the magnetization of the fluid for the spikes to appear. In the popular literature, this is often misunderstood. The theory makes it clear no matter how strongly applied magnetic field, no spikes will form unless the magnetization of the fluid equals or exceeds the critical value. That value is quantified by the formula that you see written at the top right. Rho is the mass density of the fluid, G the gravitational constant, and sigma the surface tension. Our experiment showed that the formula agrees well with the theory. Next slide, please. This is an unpublished photo of the world's first experimental ferrofluid seal. It seals the gap around a rotating shaft that penetrates a wall, in this case, a plastic cylinder. It is a one-stage seal, and such a simple seal has limited use as the maximum pressure it can withstand is only a few psi. Later, we made an important advance with compact multi-stage seals run on just one magnet. These are seen in this color part of the slide on the left, on the right. They have the ability to seal far more than atmospheric pressure. One seal for 1,000 psi was even built. The compact seals are used most often in vacuum systems. The photo at the right shows, again, a variety of commercial seals we developed at Ferrofluidics and now Ferrotech, of which some allow electric current or even special gases to be introduced into a vacuum tank through a hollow shaft with no air leakage. The seals run for years with no wear and no leakage. These seals have been termed a modern machine element. They're widely used to produce single crystal silicon, integrated circuits, solar cells, LEDs, flat panel displays, rotating anode X-ray sources for use in labs, and much more. These seals would not be possible without the strongly magnetic fluid. Kindly show the next slide. This is also an unpublished photo not seen before, and it shows a very early demonstration of levitation of a brass weight with mass density more than 8 times that of the ferrofluid, and the brass floats to the top when the magnetic field is applied. Actually, any element in the periodic table can be levitated, including osmium, with a specific gravity of 22.5. This principle is being used routinely by De Beers to separate diamonds from rocks, and by others to separate gold from alluvial deposits of rivers. A recent industrial plant to economically sort and recycle plastics is being operated in Amsterdam. I could dwell on numerous other highlights, but this is not the place. Growth in the field of ferrofluids has resembled a small sapling growing into a large tree, spawning new branches in many directions of physics, chemistry, all branches of engineering, material science, life sciences, even kinetic art. Rather, in conclusion, I will summarize. The ongoing developments over the years have demonstrated that small steps in science can open whole new worlds. I expect ongoing growth, tailored ferrofluids stemming from new science, as well as new beneficial applications and other delightful surprises in the future. And I expect that a goodly amount of it will arise from the efforts of the researchers gathered here today. I wish you all good luck in your endeavors, and I thank you for your attention.
Thank you very much, Ron. Your camera at the end was somewhat, now it's back. Okay, thank you very much for this address. Yeah, looking back into this long time of ferrofluid research, starting with a conference with about 30 people, and now we are about 200 or something like that here in Granada. Even for myself, and I'm quite long in this field, many of these things have been before my time. So thanks for this look back. I think it is quite right that the steering committee gave the medal the name of Ron Rosensweig. we thank you for coming here. We thank you, Elmars, for being here with us. And yeah, we hope that you will be able to attend the next ceremony of that way that we will have in 3 years, hopefully, with the next conference. And yeah, at that point, I can close this first Rosensweig Medal Ceremony. Thank you.